Okay, so this question, they do tell us to use trigonometry, which is very generous of them. However, we should know that it's a trigonometry question because it's a right-angled triangle with sides and angles both included in the problem. We want to calculate the length BC. They haven't labelled it for us, so we have to do that ourselves. If you want to use algebra, you've got to label the thing you're interested in, so you can maneuver it around your equations. Now, in order to use trigonometry, I need to label my triangle. Right angle points at the longest side, which gets the longest name. The adjacent side is the one touching, the one adjacent to both of the angles, so that's down here, which means the opposite side is the odd man out. I want a rule that includes the opposite, which I know, and the hypotenuse that I want to know. So that once again is going to be sine theta is opposite over hypotenuse. Substituting in, I've got sine 52 is equal to opposite 8.6 over hypotenuse x. Now I'm looking around for any nice jobs that I can do. And in this case, I can actually work out what sine 52 is on my calculator, turning it into a decimal. This is 0.788. And now I'm left with an equation to solve. With all equation solving, if there is a fraction, we want to think about getting rid of it immediately. The way to get rid of a divide by x, as represented in my equation, is to times by x. But I can't just do that over here, I've got to do it everywhere, or it won't remain equal. So my next line is 0.788 times x equals 8.6. And now I simply divide by that 0.788 on both sides. Don't panic if you see a fraction, and don't panic if that fraction involves an x in the denominator. You deal with all of them the same way. X equals 10.9 centimeters in this case. This is also the first question we've seen on this worksheet where we don't shift the sign or shift the 10 or something like that. Don't assume you're always going to do that. Look at what you've written down, look for the nice jobs, and then deal with what happens afterwards. Don't get ahead of yourself. This next question is a Pythagoras theorem question. I've been asked to calculate a length. I've been given two lengths. I don't have any angles to work with, apart from the right angle that's telling me that I can use Pythagoras' theorem in the first place. So my formula here is going to be a squared plus b squared equals c squared for Pythagoras' theorem. When I'm substituting in, I need to be very careful. First of all, let's label the side we're interested in. That's down here, BC. That's x. Remember, in Pythagoras' theorem, the two shorter sides gang up to equal the longest side. The longest side is the one the right angle is pointing towards, right? Which means the 18 centimeters is all by itself on the one side, while the x squared and the 8 squared team up to balance it out. Let's do any nice jobs that we can see. I can work out 8 squared, and I can work out 18 squared. And those are the nice jobs. Now I have to start solving my equation. So let's collect the terms, moving the 64 over this way. So 324 minus 64 takes me down to 260. And finally, I need to get rid of the squared. I need to get to the root of the problem and take a square root. And that's going to give me 16.1 centimeters. And there we are. So in the next question, I'm asked to calculate the value of that angle. Straight away we can identify this as a trigonometry problem. Once again, I want to label all my sides. Hypotenuse goes up here with the right angle pointing at it. Adjacent with the two angles touching it. Opposite is the odd man out. I want a rule involving the opposite and the hypotenuse, because I don't know nor do I care about the adjacent. The formula therefore is sine theta equals opposite over hypotenuse. When I substitute into this formula, that's sine x equals 6.4 divided by 8.1. A nice job would be to actually do that division on my calculator. 6.4 divided by 8.1, and that's going to give me 0.790. Finally, to get x on its own, I need to shift that sign out of the way. And so we're going to shift and sign to get an inverse sign of that decimal, giving me x equals 52.2 degrees. And there's our answer. Now in this final question, which you may recognize from the parallel lines worksheet, I'm asked to work out a distance mr. In the beginning this looks very complicated, but mr is this thing all the way from here to here. Let's label that with an x, because if we're going to do algebra, we're going to need a name for it. I can see a right angle down in this corner, and if I look at the outside triangle, the large triangle, then I can actually see that a lot of this information isn't relevant to me. I've got a triangle with 45 on this side, x on this side, and 117 going across there. None of this stuff in the middle actually really matters for this question. It mattered for earlier parts of the question, but it doesn't matter now. So don't get intimidated if there's a lot of information. Look for the things that you need, the things that you're interested in, and see what you can do with them. So this is a Pythagoras theorem question because I'm interested in this side and I have the other two. I don't care about this angle in here or this angle over here. Remember, the two shorter sides have to gang up to take on the longest side. And the longest side is the one the right angle is pointing at, the 117. So when I'm substituting in, my x squared and my 45 squared are teaming up to take on the 117 squared. A nice job now will be to work out these squares on my calculator. So 45 squared is 2025, and 117 squared is 13,689. Now to solve my equation. I can collect my terms, moving the 2025 over to the side and subtracting it. That gets me 11,664. And then finally we take a square root, and that's going to get me my value of x. 108, and in this question the units are kilometers, 108 kilometers. And those are the answers to the Pythagoras and trigonometry worksheet.